Now we can go ahead and use this trick to actually solve equations. So if we look at problem A, we have log base 3 of 81 equals x. So we'll use this little trick. So we've got a base on our log of 3, so we can rewrite this as an exponential base of 3. But again, they're inverses, so we have to swap the other two pieces. We have to swap the 81 and the x if we're going to write it as an inverse. So that means the x will actually go on the left and will become the exponent on the 3. And this will now equal the 81 will move to the other side. Now this becomes a question that we need to answer. 3 to the x equals 81. It's asking, what do I need to raise 3 to give me 81? Well, let's see. If you weren't sure, you could go off to the side and remember that 81 is 9 times 9. And then each of the 9s is another 3 times 3. Well, how many 3s do you have? You have 1, 2, 3, 4 3s. So that means I need to have 4 3s, which means what's this exponent I need to have on the 3? I need to have a 4 because I need 3. So I need 4 of these 3s to get the 81 I want. That is what I'm saying here. So x equals 4. Now let's look at B. On B we have log base 3 of x minus 1 equals 2. Okay. Well, again, let's do the same trick. We have a log base 3, which means I can use my inverses, my exponential base 3. But if I do that, that means I have to swap my other two pieces, my x and my y pieces. Well, that means what's going to be with my 3 now is my 2, and it's going to come in as my exponent, will equal, well, the x minus 1 is going to move to the other side. And now I can just solve this like a normal equation. Be careful, you still have to follow order of operations, which is going to tell you to do exponents first. Well, 3 squared is 9 equals your x minus 1 still. So I can solve this just by adding 1 to both sides. And that's going to give me that x equals 10. In problem C, we have log base 2 of x equals 2. So again, using the same property, using inverses, I can rewrite this log base 2 as an exponential base 2. But again, then I'm turning it into an inverse, means I need to swap the other two values. Well, if I swap the other two values, that means the exponent on my 2 that's my base will be another 2, and that will be my x. My x will move to the other side. So what does that mean? It means that my x is actually equal to, let's see, what do we have? 2 squared, which is just, well, 2 squared is just 4. So our answer for x is just 4. One last problem. Let's see, on D, we've got log base 64 of x equals 2/3. So let's use our same trick. We've got a log base 64 would turn into, using inverses, exponential base 64. But then I have to swap the position of my x and my 2/3. Which means the 2/3 will become my exponent on my 64, and my x will move to the other side. Well, they still expect me to figure out what this equals. Well, the 3 on the bottom tells me I'm going to do a cube root. Tells me I'm going to do a cube root of 64. Well, the cube root of 64 is just 4. Not quite done though. I've forgotten to do one thing. I've forgotten the 2 on top, which tells me I need 2 square whatever it is I'm getting. Well, if I square the 4 I just got, that will give me an x of 16. That's my final answer. Notice this answer, being able to come up with it, hinged upon you being able to remember that whatever is on the denominator tells you what kind of root you have.